I'm going to explain how Ethereum tokens work, and I'm going to show you how to properly check your balance for a token, because you may have had this experience where you acquire a token and then you check Metamask or Ledger Live or the Etherscan little drop-down thing, and you don't see your token, and then you panic. So I'll show you the proper way to check token balance and explain how the tokens work so you understand why they don't show up in MetaMask anyway. So in order to understand how the tokens work, we should understand a bit about Ethereum itself. And one of the ways you can understand Ethereum is as a sort of state machine. And a state machine is this kind of conceptualization of this machine thing where you have these like a sequence of states, and the machine will change states via a state transition. So anyway, in the case of Ethereum, the state, the world state, as we call it, consists of, it's kind of like a snapshot of the entire system, a snapshot in time. So it's all the stuff in the Ethereum universe that we care about, which is all of the account balances and all of the smart contract, code, storage, all of that stuff. That's the state, the world state. And that stuff changes when people do transactions, right? So if you have your initial state and someone does a transaction, send ETH from one account to another, that's obviously changing the state, because the account that sent the ETH is going to have less ETH and some other account's going to have more ETH, right? So each transaction is kind of like a state transition, except in Ethereum and most blockchains, you don't execute like one transaction at a time exactly. You have a whole block of them, right? So a miner will have a block of transactions, compute the state change that results from all of them being processed, and then they'll publish, here's the final state, basically. They'll publish the state root typically. But so the Ethereum state machine transitions to new states when a block full of transactions is mined and happens, right? So what is in the world state? I mentioned it a bit already, but it's just accounts. So in this sense, Ethereum is pretty simple. The entire world state is just a bunch of accounts. Each account has an address. It points to the account, and the account has a state, right? So your Ethereum account has a balance that may change over time. So the state for your specific account is the the balance and another value called the nonce. But it's that bit of information, and it's the same with contracts. They're just accounts as well, it turns out, and they have a bunch of information, and the entire Ethereum system is just a bunch of accounts. And so, as I said, there's the two kinds of accounts. There's the externally owned account, which is the normal Ethereum account, and there you have an external person or thing controlling the account. You have a key, a private key. These other accounts, contract accounts, they don't have a private key. They don't have, there's no way for them to like initiate their own transactions. So the Ethereum regular old externally owned accounts, they have an address. They have a little account state here, but all that's there is a nonce and a balance. And the balance is obviously the balance, right? It's your ETH balance. It's a number. And the nonce is a number too. It's just an integer. It just increments as you make more transactions. It's basically a transaction counter. It serves a purpose. It's for preventing double spend issues. But yeah, it's just a number. And that's all there is in your account. So you'll notice here, there's no like token section, right? There's no NFT section. So tokens and NFTs, they are not in your account. Like, this is a huge misconception, and I like understand why, because you think of, everyone thinks of my tokens are in my account, and it's like kind of right, but they're not actually stored anywhere in your account. You know, like if you have an Ethereum node and then you look into the storage and all of that, and you dig up and find like where your account is stored, it's just going to be this little bit of information. It's not going to have next to it like you have 0.1 YFI token and blah 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 blah. So right, so these accounts have very little. There's nothing really there. All the magic happens in the contract accounts, right? These are the Ethereum contracts, and they have an address too, of course. They have a nonce and a balance. In that sense, they're the exact same as the externally owned accounts. But they also have a storage hash and a code hash. And I mean, you can think of this, I know it's a storage hash. Essentially the storage hash, it's going to be a hash, a like 256-bit number, kind of like a signature address. And it's basically pointing to some other location on the client node storage, you know, whatever. It's pointing to somewhere else where the information for the actual storage, the data that's stored there, it's pointing to where it is, right? And same with the code. But I mean, the way to think about this is just think about it like the contract account in its state. Just imagine that the storage is in there too. And same with the code. The fact that it's pointing to a different location kind of doesn't matter. So in a contract account, you have a nonce and a balance, and you have storage. You can store data, and you have code. And this is actually how tokens work, right? What you have when you have a token is you have a contract or multiple contracts, and you have some code. And the code is like, you know, outlines, describes how the token works. And even stuff like what the token's named. You'll have a function there where people can get the name of your token. And the storage will keep track of the token holders. Okay, and I have a little diagram here. The storage looks like this. So you could imagine this is like a little segment of the Ethereum state. And you've got a couple contracts here. And you've got a regular account. The regular account just has a nonce, a balance, and an address. These ones have address, nonce, balance, and then code. This is actually from a ERC20 token contract, I think. I'm not 100% sure. I copied it a while ago, but then these contracts have storage, and the code is immutable. This section of code is, once you deploy the contract, it's just fixed. It doesn't change. It's, you know, just stays constant. But the storage does change. So in an ERC20 or any token contract, I'll talk about ERC20 in a minute, but in any contract that implements a token or an NFT or anything, you're gonna have a bunch of code there that has functions for how the thing actually works. Like, you know, how do you mint more? Can you mint more? Blah, blah, blah. And the storage is where it keeps track of who has X number of tokens and who has Y number of tokens. This storage on the contract, that is where your tokens are, so to speak. You know, if you had to say they're somewhere, they're on the contract. So if you go to the, you know, the Yearn Finance YFI token, what it's doing, that contract is keeping this record of all of the holders. This is a little Python example. It's just a dictionary in Python, it's called. And all it is like a mapping. So you map from a key to a value. And that's what this is doing here, key value mapping. So a token contract is literally just has, if you have the token, it's going to have your address in its storage and then a number, right? Like 50, you have 50 of the tokens. And then when you want to transfer that token, it's not really like coming from your account because your account doesn't have the tokens, right? You're not like sending the token from your account, really. What you're doing is you'll be calling a function, a transfer, pretty sure it's called transfer, transfer function on the contract saying, you know, I want to send the X amount of my tokens to to whatever, another address or something. And it's just going to change the storage. It's going to change the balance. You know, you have your address there, you have your balance, the balance is going to go down, and the balance for someone else in this key value thing will go up. Or if this is a new holder who didn't previously have the token, it'll create a new row and it'll put their address there and a new value. But all of it is happening inside of that contract, right? The contract is like this little self-contained ledger. You know, you can think of an entire blockchain like Bitcoin is, I mean, it's doing many things, but one of the things it's doing is implementing a ledger, right? Just really accounts and like balances, a simplified description of it, but that's what it's accomplishing, right? And a token contract is doing literally the same thing. You just have this ledger, and then you can have code, whatever code you want, defining how the token works, and you can do rebasing, and you can do whatever you want, right? So, okay, so if the way I'll show like how you find these contracts, what they look like. So for example, the Yearn Finance token, Wi-Fi, you go here, CoinGecko or wherever, you get the contract address, right? And I already have it here, but you then find the, go to Etherscan, search for it, and boom, you have the contract. And this is like the standard Etherscan contract view. So it's going to show, you know, a bunch of transactions and the contract code. And you can see here, for example, we'll talk about this in a second, but there's a bunch of functions. This is an interface. It's just like listing out the functions and what they return, and whether they're, you know, view, external. They're all going to be external, I think. Yeah, anyway. These are the functions that are available for outside entities to call. And they have, you know, basically this is implementing a token, right? Total supply, pretty self-explanatory. Balance of, you can find the balance of an address. Transfer, I mentioned, you give the recipient address and the amount, and it knows your address because it knows who sent the transaction. Returns true or false. Allowance, approve, etc. So yeah, this code is just implementing a token, and this is the token address. And Etherscan has this really nice feature where you can take the address and you can go to the token tracker page, or I mean, you don't just click the token tracker page, right? That's what I had there. And this, so you'll notice, okay, look at the address here. This is 93E. This is 93E. It just has this token prefix, where here there's this address. So here you're just looking at the standard like address or contract view. Like it's just showing, it doesn't know what the contract is. It doesn't care. This page is actually, Etherscan's been kind enough to make this like token tracker page, which is great because then it's showing you additional useful information, because there's so many tokens, right? There's so many contracts in Ethereum are tokens. So it's just providing this page to give you some simplified, like useful data, like the total supply and the price and the market cap and the number of holders. And so this is where you want to go if you think you bought some token, but you don't see it in Metamask, whatever, like don't look in Metamask for your tokens. If anything, go to like the, that's not a good example. If anything, go to your, this is just an address. This is Vitalik's address, actually. Go to Etherscan and look here. Etherscan does a good job of scanning through all the contracts, because remember, all of these tokens, they're just contracts. That's why MetaMask doesn't know. It's like missing your tokens, and even Etherscan sometimes won't show your tokens, because there's whatever, thousands, 100,000, thousands and thousands of tokens out there. And Etherscan, MetaMask, they don't know if your address happens to be in one of those token key value store things, right? They have to go and scan them all. So for the main like top 100 tokens, these services, Etherscan, etc., they do a good job of like scanning those and looking for your address. But if it's some brand new token that just got invented yesterday, then they often won't have it. And so this little viewer here is pretty good. It'll often be pretty up to date, but I've bought tokens that didn't show up, and you know, it's a bit scary. But what you do is you go into, you know, you get the contract address, you know, go to this page, just see the plain contract, then go to the tracker. On the tracker, you can go to holders, and you can now search your address. I'm just going to use this one as a sample address. So we know it has 666.6 YFI, which is a lot. So just suppose that's your address. You can just put it there, find. Now it's going to filter your address out of all of the YFI holders. It's going to find your address. If it's in there, it'll show a balance. In this case, it worked, 666.6. Boom. So we could take Vitalik's address here and go and see if he has any YFI. I wonder if he does. Probably not. No. So yeah, if you buy a token and not sure if you have any, and then you just search it here, and if you see this, then maybe you got rugged. Otherwise, you're probably fine. And yeah, I mean, that's pretty much it. So ERC20, though, there's a few things to note there. So you can implement a token however you want. Like, you can write whatever code you want in there. It can be like, it's these programming languages are Turing complete. So you can do anything you can do in like any programming language in any environment, you can do essentially with Solidity. So you can make a token do whatever the hell you want. But there's the standard. A standard was introduced called ERC20, and you can adhere to it if you want. It's probably a good idea because a bunch of the other protocols and DeFi things and wallets and stuff, they expect from tokens, generally, like most tokens are ERC20, so they'll expect a bunch of these methods, these like little functions to be there. And if they're not, then stuff won't really work, and maybe they just won't, you know, they'll ignore your token. But they're pretty basic. Some of these are optional, but name, symbol, decimals, total supply, transfer. It's very basic stuff. So ERC20 is quite broad. Like, there's lots you can do within it. All it wants is like the basic stuff. Like the ability to transfer, you know, is pretty simple. And approve. So I may as well explain approve. You know, it's like, why the hell do I have to approve every token so I can spend it on Uniswap? It's so annoying. And the reason is, you know, again, like this, the contract implementing the token is a separate thing. It's this whole side. It's not associated with your account, really. You're in their storage, you have your address, you have a balance. And so the contract, you can call transfer, because it can see, okay, this address is trying to transfer. You can see the address you're sending from, right? So it can say, this address wants to transfer, and I can see they have a balance. So no problem, right? But in the case of like a Uniswap swap, you want to, basically you need the Uniswap contract that's doing all this logic and X times Y equals K or whatever. You want, it has to be able to spend your money. It has to be able to call transfer, because it's going to transfer. It's going to need, if you're swapping from YFI to like ZRX or something, then Uniswap needs to be able to spend some of your YFI, right? And they don't actually know exactly how much they're going to spend, because there's a little bit of, the price fluctuates, right? So you'll set like a slippage tolerance. So that Uniswap contract needs to be able to spend on your behalf, right? And so that's what approve does. You approve this Uniswap contract or the SushiSwap contract to spend your money, and then you can do swaps. and then it works fine. And yeah, I mean, this is an example swap. You know, it interacted with this contract. It went through like 2 different pools, I guess. Wi-Fi to ETH and then ETH to USDC. So I think it probably went through 2 pools here. This is a Uniswap v2, I believe, but it doesn't really matter. But anyway, this contract, I'm assuming, will have an approve that has been done for this, the initiator of this transaction will have approved this contract to spend their Wi-Fi, and then they can do the swap. And yeah, I mean, that's basically how it works. So main thing to remember is your tokens are not in your account. There's nothing there except a nonce and a balance, right? So everything happens inside of these contracts, and the contracts, they're these separate little things. They can have their own little ledger. They can have their own code doing whatever you want. And yeah, so that's why, you know, for Metamask to know every token you're going to have, it has to scan literally every contract on the entire system, because it has to look through all of them to see if the token, or if the contract deployed in the last 5 minutes was a token, an ERC20 token contract, whether you have some. Yeah, so that's how it works. And yeah, thanks for watching. I will have more videos soon on, I don't know what, the EVM, I think. So thanks for watching. See ya.